also, if anybody is watching right now, starting to tune in, you don't hear any sound, don't worry. You just connect to the Slack session, daily session, and still you can Okay, so I'm back. Thanks for waiting. Whoever's watching it now. There are going to be more people joining us during the lab series itself, the lab session itself. So I'm just going to go right ahead and get started with the lab session. And later on, you know, uh, in the session, my time zone is tonight, so for you guys, it's probably a little bit of morning in the States. So, later in the session, I am going to uh, talk a little bit on the hardware, and then we're going to talk about some of the things that we are going to explore in the next session as well. Start like integrating with Arduino. I thought it'd be interesting to talk, kind of put that integration in the next session as well. And for this session, I'm just going to focus a bit more on the physical hardware as well as the PanelPilot software and also screen capture. So before we get into that, yeah, so basically what you're seeing on the screen right now is actually the PanelPilot 3.5-inch display. Um, okay, I realize that the microphone is Okay, so yeah, just let me know with a quick feedback on how's the volume of the sound and so on, and to make sure that you are able to hear me okay. Just give me a thumbs up, and let me know. Okay, so basically over here for the 3.5-inch display, there are a couple of things. One is the dual inline um, socket. This is where you actually, if later on I'll show you the data sheet itself. And on the data sheet, you'll be able to also look at what are the pins that are available, how you can interface the hardware with a controller board like Arduino or Raspberry Pi, depending on how you want to power the display itself. Um, but I think this display itself is probably good enough by itself alone. It's good enough to run the display, so that should be more than enough actually. But I think for some cases, people might want to control the display and how they want information and data to be represented on the UI. So this is where we will talk a lot about CX UX because CX UX will actually help you as a developer or a product user to know, what are the strengths of the product itself, what are the limitations, and based on those strengths and limitations, how you can actually maximize the product. All right. So I am going to switch over to the screencast, and I'm going to talk a little bit about the data sheet, the features and functions. So let's do that. Do let me know if you are able to see the display, or if you're seeing a black screen, then I probably have to. Let me just try again. Okay. Uh, okay, so please let me know if you can see my screen, the desktop. Okay, I can see it for myself, so I think it should be fine. Okay. Okay, so basically this is the data sheet for the SGD35M, which is the PanelPilot 3.5-inch M display module. All right. Basically, the software, which you'll see later, runs on Windows. It is compatible for Windows 7, 8.1, and 10. Um, there are multiple voltmeter configurations that you can use um, with the display. Later on, we'll go through the setting up of the display itself. All right. Also, you can program it using the USB interface. There is a mounting solution, so it comes with a box when you purchase the product, so you can actually mount it on the wall. Or maybe you want to mount it somewhere, in your workspace or in the industrial setting. Okay? So there's a wide operating voltage between 4 volts to 30 volts DC. Right? So
and the measuring voltage is between 0 to 40 volts DC. Okay, so basically there's this screw terminal functions, or these screw terminals that is at the bottom of the display. They actually allow you to uh, plug in the analog voltage input. All right, there's also the ground. So one thing is that next week, as we start to look at integration with controller boards like Arduino or Raspberry Pi, it's probably good to take note of which pins, is the ground and which pin is the VDD, all right, your voltage source. So don't plug it wrongly. You don't want to spoil or you don't want to spoil the hardware. Okay, so when I first got the product, now honestly, I never used PanelPilot displays by Lascar Electronics before. So before the whole lab series even started, they actually sent me the product samples, and I actually took a little bit of time to familiarize myself with the products as well. So personally, I can be very honest with you. I am not a data sheet kind of person, but I do value the importance of reading the data sheet. So, as a end user, I behave more like an end user. So, the very first thing I did when I got the product was I just plugged in the USB. I installed the software, and then I started to play around with the software and try to compile the display compile the UI, the dashboard, the meter display onto the hardware itself. So, it was only after all of that, I finally got the display running. I created an interesting meter display. And then I started to ask myself, okay, now that I've done the basic, what's next? I really need to understand more about this display to really maximize its potential. So I thought that, the lab series is perfect because together with me, this is after all a lab series. And you and I, together we're going to be exploring all the functions and features of the hardware itself. And the good thing about this lab series is that it's not just a surface level product demo. I'm not trying to sell you the product. Although I believe that by the end of uh, a few sessions or by the end of the lab series, you'll be more than enough convinced that the product will be able to help you to solve certain problems or certain use cases, right? So but yeah, during the lab series itself, we are going to explore all those functionalities and features together. All right. So next thing that we're going to do, basically, okay, what I want to say here is that this is something that I believe is important for you to take note because I personally, obviously, when I first started reading the data sheet, I always wanted to know if it accepts the voltage range, what sort of resolution will it have, depending on the voltage range that you're supplying. Right. So here in this case, usually if you're talking about voltage range, like a 9-volt DC battery, we'll be talking about this. And of course, in a real industrial use case, you might not want to put another additional battery. You might have a central battery that is supplying power to various IoT devices and displays around your facility. All right. So in that case, you probably need to take note of these few available ranges. Okay, so another thing that I would read, the very next thing that I would read normally as a product user is to look at the dual inline IDC socket because obviously, sometimes I might want to integrate with, like I said, Arduino, depending on the use case, which we will explore in the next session. And then in that case, it's important for me as a user to understand what those pins are and what they can be used for. And by understanding those pins, then I will know uh, what is the what sort of limitations are there, or what sort of capabilities are there. In this case, it's described here that it includes provision for future expansion using data buses. Um, okay. Okay, so I realized that I was sharing the screen, but not exactly the Chrome browser. So I apologize for that. But yeah, I think I maximized the screen now, so everything should look pretty clear. Right. So okay, so basically, as I was mentioning, the important part about reading the data sheet and understanding the data sheet is to know um, what sort of hardware sockets and interfacing options that you have. All right. Okay. So that's basically for the data sheet itself. I think the rest of it will be something that we will learn uh, on the hands-on. And yeah, that is a unique thing about this lab series. So I am going to switch the uh, screen sharing over to the webcam. Okay, let me just. Okay, so the USB cable that you will need is actually this. There's two kinds of micro USB cables. So I am going to try and focus a little bit. Okay, so yeah, you should be able to see. So there are two kinds. Let me see if I can find another cable that I have on my table. Okay, so there are two types of micro USB. So it's important to note which one you want to use. Obviously, if you look at the holes, the shape of it is quite easy to tell. But if not, you need to get the USB A to micro USB B. I think that should be right. Yeah, micro USB B. All right. So with this, what we're going to do is we're going to plug in. Okay. Okay, so it's already preloaded with a display of its own. So I'm going to turn off my desk lamp so that, hopefully it will look better because the screen is actually quite bright. So, but yeah, so basically right here you see the meter displaying a default with no reading. All right, there's no reading obviously because we're not reading anything at the moment. Um, and then the next thing that we want to do just to quickly get started. Oops, sorry. Uh, okay, I'm gonna just share my screen now. Okay, so this is basically the PanelPilot software that you have to download from the Lascar Electronics website. Basically, I would assume that as a end user, you would have downloaded the software. You would have followed the URL on the product sheet that was given when you bought the product itself. So we are just going to go straight into setting up and configuring the display. I'm using a VM, so if it looks a little odd occasionally, just bear with me. Okay, so while this screen is loading, there are going to be a few options that are going to be available. Actually, there are more than a few options. When I first play around with the PanelPilot software, the app, I realized that there were so many templates available to choose from, and as a end user, especially if you are not somebody that wants to go into hardcore development and coding, honestly, this option is the best for, I would say, a non-technical user. Okay, so you can see from this display, on the right-hand side, there is a filter for you to choose the meter type that you are working with. In this case, ours is the 35 amp. And then there are a lot of different configurations that you can choose from as well. Okay. Like for example, I'm interested in voltage, analog. Let's choose digital alarms. Okay, so yeah, the last time around I chose this, which was quite straightforward and easy to set up. So we're just going to go with this for now. But there are a lot of really cool displays. They look really nice. Honestly, before I even play around with the software, if I speak as a product user myself, I would say that they really surprised me as a product, because I honestly didn't expect I did not expect a lot from the product itself. So in the overview session for the lab series, I did mention this, that PanelPilot displays really did surprise me a lot as a end user. So if somebody as technical as myself would be surprised by what they can do, I think that for end users, it's going to be really good for you. It's going to make your life a lot easier, put it simply. Okay, so we click next, and then we're gonna choose the colors. Okay, so let's say for labels. Now, normally for a very small screen like that, with little screen estate and with a default black color background, I honestly strongly recommend using high contrast colors. For wordings especially, you might not want to confuse the user. The thing is, you can, for example, let me choose. Okay, so you select the color that you want, then you click on the element, which is actually quite user friendly. I think the guys at Lascar Electronics, when they developed this tool, they really thought about the workflow. Because normally in a standard environment, people would assume, especially because I use so many software development tools over the years, I've used so many wizard-based software products. The flow was always to click on an element and then choose the color, right? So, but I think this is good, whereby you can just pick the color and then apply it to the element itself, uh, which is, yeah, honestly very good. So I like orange because online lab series is orange. And then let's say the label, let's pick yellow. Although this yellow is a bit light, so I don't recommend it. But depending on your industrial application, depending on what you want to display as well. So certain colors might represent certain things. Yellow could be a representation of warning. So red is usually danger. So depends on what you want to do, especially for the display itself. If say you are alerting people about something that they need to take note, then I would recommend using red and not white. Uh, White is good for normal text display, and they usually psychologically from a UX perspective, when the user reads and look at white text, it doesn't catch their attention as much as seeing red text, so red colored text. So these are some of the things that you need to think about when you are developing a UI. All right. So we're going to change the label back to white color, or perhaps green. Yeah. Hmm. All right. So another thing that you want to do is probably the colors. Depending if you want fanciful. Now, honestly, in an industrial setting, usually the most standard colors are green, orange, red. If you are talking about measuring capacity percentage of maybe a fuel tank or so on, power capacity and so on. Um, but if, say, for example, we want to measure coolness of a room, maybe it's for a uh, freezer, a massive freezer for frozen food, right? So you probably would want to have a different kind of color. So in this case, obviously this is 0 to 100%, so it doesn't really apply. But you can actually set the colors individually, which is what I like as well. Of course, it's you have to individually select. But I don't know. Depending on whoever has used this before, what's your experience like with the products? Have you actually had to? I mean, have you discovered an easier way to set the colors rather than doing it individually? Because yeah, I can't drag it. So anyway, let's just add the colors and say for when it gets really really cold, maybe too cold, maybe the freezer is spoiled or not working. Maybe we can add dark blue. Yeah, but okay, so this is the thing that I want to talk about as well. When designing a display like that, a dashboard, and the background is black, don't try to use colors that are too dark, because people sometimes, if they are busy and rushing around, honestly, they'll just miss seeing what the color is. So yeah, just take note of that. Oh, hang on. I didn't realize this before. I can set it to white. Ah, okay. Let's do the label as black, text as black, and black. Let's change the background to white. Okay, so now the blue obviously is not as obvious anymore. Okay, so yeah, at least this looks a little bit better. And then if you, okay, so if it's not industrial, if it's like I say, it was a freezer, right? Then you probably want to set the color to something that matches the display of the rating itself. So that would be good, because then psychologically, whoever is working with the display or using the display can immediately understand what it represents without actually physically looking at the numbers itself. So that is one good thing to take note. So okay, let's just go next. Okay. So here, for label one, basically, what are we going to look at? So Let's see. We are going to look at degrees Celsius. In Asia, this part of the world, we follow the British. So I believe that in British is also the US. They follow the Fahrenheit unit. So depending on what you want to measure and what you want to display, you can actually choose it from here as well. All right. So in this case, let's just select degree Celsius. But this percentage probably is a bit not relevant for. Let's see if we can set something as minus. Okay, negative 10, negative 35, negative 5. Okay, so on this screen, this is where you need to set in terms of the voltage reading that we talked about earlier in terms of the voltage resolution. So here you start to talk about like, okay, let's select how many volts we need, and then it's going to be positioned at which bar. All right, so we're going to set this as 0. Okay, so well, okay, they already set 0 to 10, so maybe we put it as 9. This you can also set and decrease the bar position as well. Okay, so this is just something that you can take note. Next. Okay, so here you can choose to set the alarm as well. For example, if let's say we decide that we want to display a blue icon or red. So depending on the industrial application, for example, in the use case that I'm creating right now to measure the temperature in a meat factory, for example, meat factory usually they will have a lot of large freezers, and in terms of that, I normally would put blue color because it goes with the theme, and it doesn't confuse the person who's looking at it. So it really depends on the nature of the application itself. So that is something that you should consider. Okay, two independent alarms, one for high, one for low. Activate. Okay, so basically, if let's say 1, right? So this is basically the lower value that you want your alarm to go off, whichever alarm, all right? And then if you hit a much higher value, say the threshold limit, at what value do you want the alarm to go off? All right. So here for example, we put 8.5. Okay, so here the logo is probably not as the logo is probably not relevant, but I just want to select it and show you that you can actually add your logo. me just add this. Okay, so on my end, I know that the video for you guys, usually it will kind of like a few seconds in between me talking and you hearing what I'm saying. So here, basically, I've already added a logo that you can see for my desktop environment. And then on the right-hand side, here you can actually set the default brightness. All right, so depending on how bright you want the display to be, it will actually consume less power, which is also good because in case you want to, you want to conserve energy, you want to conserve power, and sort of things. Another thing that I also learned and discovered is that for the actual hardware itself, you can actually there is a way to do low power mode, low power consumption, or sleep mode. The onboard chip, the onboard processor actually has that, and though I have not actually dig into that and figured that out yet, but in the future lab sessions, I am going to share how you can actually enable those low power sleep modes and so on, how you can wake the display up, the sort of thing. So we're gonna do all of that in the next few sessions. Okay, so we're gonna click next. Okay, so here it will just tell you, the summary of everything you have done and selected. For example, I'm displaying a digital bar graph meter. I want to have my splash screen on for 3 seconds. In terms of the scaling, all right, 0%, in this case, the label -5 degrees will be at 0 volts, and then at 100%, basically at -30. You can flip the other way around as well, because I think in this case, it's just an example. But if we were to go into a real application, I think that at 9 volts, it will be -5. And then if you reduce the voltage down to 0, then we will say that it's reaching a critical temperature. Obviously, normally you shouldn't be 0, because if it reaches 0 and you're using an external board to control it, you will need your power source as well. So it depends on how you want to engineer. You can have the microcontroller board powered by a different battery. But in most cases, normally you will use the same battery because you might not want to have too much power going into your display project. Okay, so we'll go into that as well in the next session, and then we will look at how to actually manipulate your display module using some external components. Right, so here you can have the option to save the configuration, but for this particular live session, what I'm going to do is I'm going to upload the configuration to the meter itself. Okay, so while it's loading, I'm going to go back to the hardware display. Okay, we'll give the program loading a couple of seconds to load. Okay, so you can see that it's refreshing itself. with the new display that we have actually just designed from the template. Okay, so I basically loaded the display. You can see that the logo is on, which is really nice. I really like this. And then obviously, we start with 0 degrees, and there's the alarm icon that we have selected earlier as well. So you can see from here we have the -5 and then -30. So next session, we are going to make use of some temperature sensors, and we are going to integrate it with Arduino Uno. And those are the things you probably want to prepare since I'm telling you now during this lab session. If you want to follow along as a product user in the next session, and you are actually working with Arduino or Raspberry Pi, um, the application is pretty similar. So next week, I will see you again here, and then we're going to talk about the integration between Arduino temperature sensor as well as the uh, PanelPilot M display. All right. So with that, I think today's session is quite short and simple, and I like to keep it that way, especially we're just easing you into understanding about display. And definitely, if you are a potential product user and you are a new product user, you are thinking about buying this product, I think this is more of an overview for you, and also to see how simple it is to set up the display on your own without actually needing any technical knowledge about it as well. All right. So with that, thank you very much. I really appreciate the time that you have taken to watch this video. Um, I know that earlier on the video, the audio was a little bit patchy, but yeah, everything looks like it turns out pretty well. So with that, thank you guys. I'll see you here again next week, same time. All right. Bye.